Hi 35. In the previous lesson, we learned that bearings of a point A from another point O is an angle measured from the north at O in a clockwise direction and is always written as a 3-digit number. We also learned that we always have to make use of alternate angles when there's two norths, and we also make use of interior angles where they add up together to be 180 degrees. So today's lesson, we are going to explore what happens if the original point is not from O, meaning I asked you to find the bearing of A from another point or B from another point. So let's quickly take a look at practice 6. Practice 6. Okay, so find the bearing of A from P. So now P is still at our origin. The north is drawn for you. Okay, so A from P will be the angle from north to A. So this is still quite simple. It is 55 degrees. B from P would be this big one over here, which is 180 minus 15, which is 165 degrees. But moving forward, we might experience things that are not from P anymore. So let us explore bearings of P from A. So let's take a look at P from A. We first draw the north at A. So remember, your pen must always be pointing towards the north. And now I'm going to turn all the way until I reach P, which is this angle over here. The issue is, how can I find what is this red color angle over here? This is where I need to make use of alternate angles and interior angles. We have calculated previously that this is 55 degrees. By alternate angles, we realize that the red color angle that I have labeled using a question mark must also be 55 degrees. So therefore, the bearing that I am looking for, my pen has to turn from north all the way until here. And I have traveled 180 plus the question mark angle. So therefore, my bearing of P from A will be 180 plus 55 degrees, which is 235 degrees. Next, how about P from B? Since it's from B, I will have to draw a north at my angle B. So let me first start off by drawing a north at B. Since bearing says that we have to turn clockwise, the angle that we are looking for will be this angle here. As we can see, the red color angle will be 360 degrees minus this tiny angle here, which I am labeling in purple. And what is this small angle here? We have to make use of alternate angles again. The alternate angles is located here. So by alternate angles, my purple color angle is 15 degrees. So therefore, the bearing of P from B will be 360 degrees minus 15 degrees, which will be 345 degrees. Lastly, let's take a look at how we are going to calculate the bearing of P from C. Since it's from C, I have to draw my north now at C. So let me draw a north at C now. And let us think, what is the angle that we are looking for? Since we are turning clockwise, this is the angle that we are looking for. And we know that it is 90 degrees plus the purple angle. And how do we get the purple angle? We get it by alternate angles again. So using alternate angles, we know that the purple angle is 47 degrees. So therefore, the bearing of P from C must be 90 degrees plus 47 degrees, which is 137 degrees. Let us move on to some examples involving bearings. Let's take a look at example 7. At 1 p.m., ship A and ship B leave the harbor and travel at two different directions. Ship A goes at a bearing of 40 and ship B sails at a bearing of 310 at a speed of 12 kilometers per hour. Calculate the distance at 3 p.m. So at 3 p.m., it means after 2 hours. We know that the ship B has sailed 24 kilometers and ship A has sailed 30 kilometers. So we know that the length this is 24 and the length here this is 30. So what is the distance apart? By bearing, we know that the remaining angle here must be 50 degrees. And we realize that the triangle that is formed between H, B and A is a right-angled triangle. So we can use Tuakaso to find the length AB. So we can say that tangent, don't even need to use Tuakaso because we have 90 degrees. Using Pythagoras theorem, AB square must be equals to 24 square plus 30 square. So AB must be equals to 38.4 kilometers. Please pause the video if you need more time to copy. I will now move on to example 8. In the figure below, A, B, C are positions in an amusement park on level ground. We can see the north here. Find the bearing of B from C. So since I am looking for the bearing of B from C, I have to draw my north at C. So I draw a north at C. And I am looking for this angle over here. Again, I know that it's 180 degrees plus something. And what is that something? The something can be found using alternate angles or interior angles. In this case, I will use interior angles first to find, and I know that the angle that I need to add would be 180 degrees minus 115 degrees will be 65 degrees based on interior angles. Therefore, the bearing of B from C will be 180 plus 65, which is 245 degrees. Now, how do I find the length of AC? I have two angles and one side. I can use sine rule to find out what is my unknown length. I first need to calculate what is this third angle because it is opposite the 250 degrees. Without that, I'm unable to use sine rule because sine rule requires us to use opposite side. I have found out that this is 47 degrees. So using sine rule, 250 over sine 47 must be equals to AC over sine 65. Cross multiply, we will have AC sine 47 equals to 250 sine 65. Therefore, AC must be 250 sine 65 divided by sine 47. Therefore, AC must be equals to 309.8063, which is 310 meter, bracket 3SF. Due to the limitations of the app, I can only make a 15-minute video, so I need to move on. If you need to copy, please pause the video and copy. Let's do the last example today. Okay, now this practice involves bearings and cosine rule. The diagram shows the position of three towns, A, B, and C. Calculate the length AC. I realized that in order for me to use the cosine rule, I need to be able to find out what is this angle over here. So what can I do? I observe that I have two norths. When I have two norths, it means that there's an alternate angle or interior angles over here. And obviously, we see that there's an interior angle over here. This means that angle ABC will be equals to 360 degrees minus 60 degrees minus 238 degrees, which gives me 62 degrees. So now I know that this is 62 degrees, and I can use my cosine rule to calculate what is my length AC. So I will write out my cosine rule now. And here we go. Here is the cosine rule formula. After calculation, AC will be equals to 49.4220. AC is 49.4 kilometers. Last question. Find the bearing of C from A. So if I want to find the bearing of C from A, I will need to extend the north. And I am looking for this angle over here. So it's quite simple. It will be 120 degrees plus angle CAB. To find angle CAB, since now we have angles and length, we are able to use sine rule to find angle CAB. And I will be writing out the sine rule for you. We form the sine rule, we cross multiply, we sine inverse, and finally angle CAB will be 79.3 degrees. Please remember that I'm not looking for sine CAB, I'm looking for the bearing. So the bearing will be 120 degrees plus 79.3, so all in all 199.3 degrees. Thank you so much for paying attention to today's video. This is all. Please scroll back if you need to complete and copy them down in your notes, and please spend the remaining time to try practice 9. Just a hint. The shortest distance from A to BC is the perpendicular distance, and we will use area or tua ka so to solve. Thank you so much. I will go through practice 9 in the next lesson.